Hi, this is my old man Jethro. In this video, we will explore the transformations of radical and rational functions by using their parent functions. The parent functions that we will explore in this video are quadratic functions, exponential and logarithmic functions, radical functions, rational functions, and even trigonometric functions, Dave. What? Trigonometric. That's right. This lesson is incredible because it helps us see the relationship of parent functions of many types of functions and the transformations of those functions.
So I started out with this nice little chart up here, and what we're going to do is we're going to just write down several types of functions, their parent functions, and then the rule for translating left and right and up and down. You might remember from studying any types of functions, the translation left or right and up and down is x minus h and then a plus k. And you have to be careful with this minus. This is the left and right translation, and this is the up and down all out there by itself. Now, we recognize the parent function of a quadratic function and the basic translation of the function, and now we're going to look at that for some other functions. So the next one that I'm going to look at is an exponential function. Exponential function, and we've got a basic exponential function with a variable in the exponent, and that's some base raised to the x. So that's b to the x, and I'm just going to show you that the translation of the exponential function is b to the in parentheses x minus h and all of that plus k. Now we're just going to come down here and write all of these, and you'll start to see a very nice pattern for remembering left and right, up and down translations. How about logarithmic? We have a basic logarithmic function. We can call that log base b of x. How about that? And our parent function is translated by the log base b of in parentheses x plus h, x minus h, just as the others, plus k. I was getting ahead of myself on that. Zoom out just a little bit. Let's try another one. How about radical or square root functions? I'm just going to say a square root function. And let's say f of x is the square root of x, the most basic of all square root functions. The parent function is f of x equals the square root of x. Now, if you were working out a pattern on how to translate this function using the same rules, we're going to keep the h with the x under the radical. X minus h, and then off to the side we've got a plus k. Let's try rational functions. Do we remember the parent function of a rational function? F of x is 1 over x. It's a rational function. We've got a variable, a ratio in the denominator, and because my left or right translation is going to stay with that x, it's going to stay in the denominator, and we're going to get 1 over x minus h plus k. And now let's come on over to even getting into a little bit higher level. We can talk about trigonometric functions, and there are many types of trigonometric functions. I'm just going to do the basic sine function. F of x equals the sine of x. And a little bit later on, if you have not studied, the parent function f of x equals sine of x is a wave, and it has many very cool and interesting properties. But if we wanted to translate it, we would do the same thing. We would take f of x equals the sine, get those parentheses because the h remains with the x minus h plus k. Now, just for your information, when you translate left or right, when the function moves left or right, in a trigonometric function, that's called a phase shift. And we'll learn all about that stuff as we get into trigonometry, pre-calculus, and even AP calculus. Now let's just talk briefly about how to use these formulas and translate left or right or up or down from the parent function. And we're just going to describe the translations. So the first one, I'll give you an example, and then maybe we can work through some other ones using this one as a model. The first one, let's say f of x equals x minus 3 squared plus 2. Now, because it's x minus h and there's already a subtraction here, it's going to shift left or right 3 units and up or down. Now, the way I look at it, and it's not the most technical way, is I always say, well, -3, you would think it goes left, but because there's a negative in the formula already, the h is a 3. And so this shifts in a different way than you would expect. So this is a right shift, 3 units, and the k is as it looks, or as it should be, up 2. So this is right 3 and up 2. That means from the parent quadratic function, this function will shift all of its points right 3 units, 1, 2, 1, 2, 3, and up 2 units, and the new translation or the movement of that parabola, because it's a quadratic function, will be right 3 and up 2. So we're going to use that for all of these functions, and we're just going to describe where it's going. Now, how about you try these? Identify the function and then describe the translation from the parent function.
How old are you, Jethro? Well, you multiply 15 times 7 if you can, Dave. Thank you for watching.